Okay, so this is new. We haven't done any of these yet. This is solving trig equations using identities. So what we're going to be doing is taking our list from the formula sheet and we're going to use that to help us solve things. Well, when do I need to use that? If you see anything that's got a double identity, that's an automatic yes, I need to use identities to solve it, because as soon as there's a double angle, we have to replace it with one of these before we can even begin to solve it. So let's take a look at a couple of examples. I have cos 2x. Now I have to make a choice. Which one of these am I going to use? I'm going to use this one because what it does is it'll put everything in terms of cos, and it'll be easy for us to solve. So cos 2x is going to be replaced with 2 cos squared x minus 1, and then I have this here, which is plus 1 minus cos x, and that's all equal to 0. So I am going to gather like terms. We find these cancel, so I have 2 cos squared x minus cos x is equal to 0, and I'm going to factor out a cos x because it's a binomial. So I've got 2 cos x minus 1 is equal to 0. My two factors are cos x is equal to 0, 2 cos x minus 1 is equal to 0. So this one is cos x is equal to 1/2. We need to solve it over this domain. So using the unit circle, find where x is equal to 0 on the unit circle, and that happens at pi over 2 and 3 pi over 2, and find where x is equal to 1/2, and that happens at pi over 3 and 5 pi over 3. And they're not asking for the general solution, so that's all I need to do there. All right, we're going to take a look at the next one here. I only have one choice when it comes to replacing sine 2x. So if you take a look, sine 2x is equal to 2 sine x cos x. And again, whenever there's a double angle, you have to use an identity to get rid of it. It's the only way. So 2 sine x cos x plus cos x is equal to 0. I'm going to take a cos x out of here, and I'm left with 2 sine x plus 1 is equal to 0. So I have cos x is equal to 0, and sine x is equal to negative 1/2. I just solved that. Again, we're going to use the unit circle, and where is cos x equal to 0? In this domain, where did I put the unit circle? So cos x is equal to 0, where x is equal to 0, and that is here, and that is here. And our domain is negative 180 to positive 180. So my two solutions are negative 90 and positive 90 for that one. And then where is sine x equal to negative 1/2? So that is, where is y equal to negative 1/2 on the unit circle? And that is right here, oops, right here, and right here. And again, that's with we're looking at all the solutions from positive 0, 0 is not positive or negative, so 0 to positive 180, and 0 to negative 180. So my solutions are negative 30 degrees, and if I go all the way to here, that's negative 150 degrees. So there are my 4 solutions. All right, determine the general solution for the following equations. I'm gonna let you give these two a try, and I'll come back and do them both for you.